ahead and get going on our next section here, which is about data storage and sharing best practices. Oops. So I'm going to present this information. The content is originally made by Lisa Gerhardt, who is our sort of one of our many storage and data experts at NERSC. So hopefully we'll be able to answer all of your questions, but if you ask some really tough questions, we'll probably uh, ask Lisa and then get back to you. But for the most part, I think we can probably handle it.
Yeah, and any questions that we can answer today, we'll have appropriate domain expert get back, and the PDF of the Q&A will be published on the event page.
Mhm. Perfect, thanks. And Charles, can you remind me the timing for this one? When should I aim to?
Let's see. Maybe as long as you're done by probably by 2.
Okay, that's
I'm
11.
sorry, 11.
Yeah,
Yeah, I'm
no, that's
sorry.
okay. It's like, uh-oh. Okay, great. Perfect. Okay, let's get started then. So let's go over our file systems. We have several. And so basically want to go through what they are and what they're all, why are there so many and what are they used for? So if you remember, this is our entire system. So Perlmutter, there's Perlmutter, which is all the compute, but then there's other parts of the system, which is some of the storage and some of the other services that we provide as part of, when we say Perlmutter, we really mean this entire sort of system of things. So we're going to talk about these particular parts of the system, which is our storage. Okay, so I used to, okay. So what we've done here is I've sort of separated out the different types of storage we have and then ranked them in kind of two different ways. So one is increasing performance. So at the top of this list is sort of the most performant part of the system in terms of if you were to keep some data stored in there. And then the capacity increases the opposite direction. So you kind of have this trade-off between performance and capacity, at least in this case. So we have, of course, the memory on each node. That would be great if we could just store everything in memory, have it right there available to us. But the memory on each node, we have significant memory, and you can go back to the previous slide, or even in our documentation, we mentioned how much memory is on each node. But it's really that's like gigs compared to some of the actual storage locations. The next best one is called Scratch. So this is 36 petabytes of SSD storage. It's a Lustre system, and it is the sort of bandwidth, the data transfer speed is 6 terabytes per second. So this is a huge data rate, which means it can be really good for when you're running a job and you need to be saving data or loading data and doing a calculation and then writing it. We recommend using Scratch for that purpose. But it's not huge, right? So because it's very performant, we don't have quite as much of it, and everybody gets a certain amount of Scratch available to them. As you heard me mention in the previous talk, sometimes you may need a little bit more. So your sort of default quota that you get when you become a NERSC user is 20 terabytes. Um, but let's say you're going to run some calculation or something and you expect to produce maybe 40, 50 terabytes of data. You can ask us to give you a little bit extra space for a couple months so that you can do those calculations. But then once you do those calculations, what we're going to recommend is that you move those to one of our other storage locations, which is larger. Um, and the next best one would be our community file space. So this is the space that you get when you have a project. You get allocated a certain amount of space in our community file system. This is a 114 petabyte HDD system. And so the data rate is a little bit lower, but there's more space on there for everybody to use. And you also see this thing that says temporary versus permanent. Scratch is actually temporary, which means after a certain amount of time, if you don't use it, you lose it. So if you have, really old files sitting, well, you wouldn't have old files sitting around on Scratch because we purge it regularly. The that period of time, I believe, is about 8 weeks right now. That number can change, and so the best way to know is to check our documentation that's always kept up to date on when that purge threshold is versus the community file system, which is permanent as long as you have a project on NERSC. So if for some reason you have a project and then the next year you don't, you would need to move all your data. But it's permanent while you have a project. So we don't do that purging process. Only if your project ends and you're no longer a NERSC user, or your project is no longer using NERSC, then that data would need to be moved. And then the biggest, least performant but long-term and largest space is our tape archive. So this is called HPSS, High Performance Storage System. I don't remember what the last S is. Um, but this is a huge amount of space, and it's for I don't know. It's we gave a tour a couple weeks ago to a bunch of very sort of younger undergrads, and I had to ask them if they knew what a tape was, like a cassette tape. A lot of them did know what that was, but these are literally little cassette tapes, magnetic tape. It's very stable, and it's very low energy. So once you put something on a tape, if you ever had cassette tapes, I had like a cassette Walkman that I used to use. But if you remember, once you have it on tape, you don't have to, there's no energy cost of just having the tape there, sitting there, right? So it's really good for long-term storage because there's very low energy cost and it's very stable and reliable. Um, so that's sort of those are our main file systems. And then there's two more that are a little bit different. One is called Global Common Software. It's a small space, but it's mounted read only on our compute nodes, which means it's really, really fast for quickly loading in some software, your software stack. We really recommend keeping it there because anytime you have this sort of read only mount, it just makes the performance a little bit better. So this is good so you're not going to store data here, right? You're going to use Scratch for that, but you can use Global Common Software for your software to quickly load it in and use it for computation. And then we have a space called Global Home. If you read the beginner guide, I put it in the Q&A. I wrote this beginner guide, and like I mentioned earlier, I really like analogies. So the entire beginner guide is written as an analogy to a house and different parts of the house. Um, Global Home is basically where you enter into the house. So if the system Perlmutter is a house, this is your foyer. This is like when you first get through the door. It's good for just keeping a little script, maybe put your umbrella down, right? But you're not going to sit there and cook a meal. You're not going to sit there and do an arts and crafts project right when you enter the door, right? So this is Global Home. It's just a space for keeping couple small things. It's a very small amount of space. It's 40 gigs. So everything else here, your quota is in terabytes. Well, I'm not sure about Global Common Software is probably also in gigs, but Global Home, the space that you get when you first enter your login node, that's where you land. It's 40 gigabytes, and it's really just for keeping maybe like a templated batch script or something like that. You're not really going to store things there. In general, we have some policies about data storage. So we always will provide you with a means to store, manage, and share your data. And this is part of doing science. You might need to share with collaborators. You obviously need to keep your data around. So for example, I'll talk a little bit more about why might you use that tape archive? Well, if you wrote a paper and you're done with that data for now, but you want to keep it because you might need to refer back to it or you might need it for reproducibility reasons or whatever, we provide that a means to store data for long periods of time versus Scratch, which is something we provide for doing the really performant, huge amounts of data creation really fast on our system. Um, these resources are meant for active allocation. So as I mentioned, if your project ends or you don't have an allocation on NERSC, you will need to move your data. And that also applies to the tape archive, I believe. I don't remember all of the specifics in terms of like how long we keep it and how long you have to move it. It's not a long period of time. We a lot of our systems are slightly oversubscribed, so we need all of the storage space for people who are actively using NERSC. So if you are no longer going to be using NERSC, it is important that you move your data quickly so that you don't lose it. PIs are able to request a variety of different things. You can request help with moving data around if you need to, transferring it, so forth. So if you're not a PI, but you know that something like this needs to be done, your PI can work with you on that. Um, and then we provide protection for your files using Unix file permissions. This is something that is based basically on your user and your group ID. It's your responsibility to make sure that your files have the appropriate permissions. There are default permissions based on where you put something, and those are all listed in our documentation. I think our Unix file permissions page of the documentation is the most visited page. So it's very common for people to go there and figure out, okay, if I store this here, what are the permissions going to be? How can I change them if I need to collaborate, if I need to share? And that all that information is there. If you need help, there are certain changes that you yourself may not be able to make, but maybe we can make for you. And that should also be outlined on that either the file permissions page or in our policy information. But in general, your data, we obviously have people keeping track of things, but we can't track everything. And so overall, it's your responsibility to make sure that the data that you need, that you're producing is being managed and backed up appropriately. If something goes wrong, you can always reach out to us and say, hey, I meant to do this and something went wrong. Like, can we recover it? Blah, blah, blah. We may or may not be able to. But overall, try to keep track of all your data. If you come back to us a year later and you're like, oh, I did this thing and where is that data? We may not be able to get that back for you. So let's go back through and just go through the more specifics on each one that I mentioned. I showed you in that kind of hierarchical diagram. We have, like I mentioned, global home. So this was actually at the bottom of that hierarchy. It's very small. It is permanent, but it's really not meant for you to be running your jobs. It's really meant to just store a couple things, you know, uh, a little bit of source code, maybe some shell scripts, something like that. And once you're on the system, you can get to it by doing cd, which is a command in your terminal that means change directory. And we provide the location of it via this environment variable home, which you can access by typing in $ and then capital HOME. So that'll take you to your home directory. For some reason, you've ended up somewhere else. We also keep snapshots. So there's a couple of the file systems where we keep snapshots. These are basically a 7-day backup. So up to 7 days of data are kept, and if you need to revert to those, we have instructions on our documentation of how to access those and quickly recover data if it was in the last 7 days. That 7-day number may change. I believe it's 7 days right now, but you can always check. Again, our documentation is the best place. When we make a change like that, if it's a significant policy change, we will update the documentation so you can know exactly what that number is. Our community file system, so this is that permanent larger storage. It has medium performance. So you can still, we sometimes tell people if they need to have a bunch of data done, calculated or worked on in some way, processed, and it doesn't fit in your Scratch, depending on what kind of job you're running, you could actually just um, run it from the community file system. It's not the most performant, but it's still performant. And so this also has snapshots, again, the same as this home. We keep track of it for 7 days. You can revert back to things if you need to. And the best part about this is really good for sharing data within your research group. So you can so um, your project on NERSC has access, everybody in that project will have access to um, probably read access first. I don't remember exactly. Definitely not just write for everything. But it's a good way to share. You can change the permissions if you need to, or you can save something into another person's folder or whatever, if you want to share something with them. So this is where that Unix file permission docs will come in handy, and you can check specifically, unlike home where people can't get in there and look at stuff. CFS, people, your other collaborators can get it if they're on their project, they can see it. And just like for home, we provide um, a environment variable called CFS, so you can quickly access your CFS space using that environment variable. Oops. Okay. And then Scratch, as I mentioned, is large, but it's temporary. So right now, this purge policy is 8 weeks. Well, it may change. So I might I need to not have this hard coded in here. It's been 8 weeks for a long time, but it could change for some reason, especially with the new system. That could be different. It's very highly optimized for read write. But not long-term storage. Just say not long-term storage. So again, that in that 8 week period, it's going to be there, but you can't leave things there for, or you shouldn't expect to leave things there for more than 8 weeks. It after 8 weeks, it could be gone. It's not backed up. Because it's temporary, it's we're not doing the snapshots the same way, or there may be another reason, but it's not backed up. So things will be in there for 8 weeks, and then if they're gone after that. So we really recommend this as a space for staging your data before or during performing different calculations. And like with these others, you can access it by doing CD and then using the environment variable Scratch. Okay. Then we have this long-term storage, HPSS. Yeah, high performance storage system. Okay, I remembered that correctly. Um, so this is something that you should not intend to access frequently. It's meant to be archival. So once you are finished with you ran all your data in Scratch, you put it into CFS to share with your collaborators, you did your analysis, you wrote your paper, it got accepted, it's all done, it's published. Now you're going to take all that data and you're going to put it into HPSS. And so there's some more specific information here, but if you're going to use HPSS, I highly recommend looking through the documentation page. I'm not an expert in HPSS. Actually, I don't think I've used HPSS. So it would be really important for you to just check out what are the best practices specific to using HPSS. I think I have a slide on that in here. Oh, great. Okay, so um, okay, some of these are, sorry, one moment. I'm snowed in, so I'm not able to get to my house where I don't have these problems of a landline. Okay, so this some of this information is repeated, but I just want to share that the quota, again, the quota that you are given on Perlmutter Scratch is 20 terabytes. And it's the reason I say soft is because um, I think basically there's a little bit of a wiggle room. So if you're running a job and it goes over this, I think it won't kill the job. But after 30 terabytes, you would need to request um, to have this quota increased if you want to continue to use your Scratch space or even run jobs. So there will be times when you can sort. So for example, if you go over the 40 gigs, which is your home directory, will kind of ask you, well, we will limit your ability to do certain things until you move your data around. For Scratch, there's this little bit of wiggle room, but then at that point you need to move your data so that you are within the quotas again. I'm going to skip that for now. Um, I mentioned this global common software. This is another one of our systems, and I mentioned it's for your software stack. And so just to drive that point home, this is a plot that's showing the speed at which the system is able to read information from certain different file systems. This was over the course of several days. I think probably actually not even last summer, a couple of summers ago. Um, but you can see here, so you want this, basically you want this number to be low, which means that it read it really fast and was able to use it and go and do computation. The lowest number in here is something called shifter, which is a container system that we don't, we still have shifter. I think now it's a different system now, which is the fastest. And you'll hear about containers tomorrow. But the next fastest is this common. So if you keep your software, in global common software, the load performance is enhanced significantly, and that's why we recommend putting your software stack into this global common software just to make things really, really fast. Um, okay, so oh good. Okay, so I do have some slides in here about the specifics of global common software. It is set up for group read permissions. So yeah, I did mention this. If you put something in CFS, the other people on your project, which you'll know based on the project number, that a lot of them have an M beforehand, not all of them. Some of them have M and then like a couple numbers. That's your project. And it means that other people in that project would be able to CD into, if you have your name, like my stuff or whatever, they could go in there and they could potentially see it, right? And you could, so the benefit of that is if you want them to know, okay, here's this file, you can go in there and change your own permissions to make it so that they can make a copy and use it for whatever they need to do, or just use that copy, whatever. This is meant to make it so you can collaborate with other people in your project. Here it says it's not for intensive IO. It's not for intensive IO, I guess I would say. We would recommend if and when possible, use Scratch because that's going to make your performance the best. But you still can use CFS when you're trying to run your jobs. If you expect to produce quite a bit of data, it's still um, able to do that. It's still performant. It's just not as performant as Scratch. So just again, if you need to access the space, you go CD CFS and then your project number. If you just do CD CFS, you'll basically see a giant list of all the projects. So you'll still have to continue CD and then do your project number. And then you should be able to make a directory. So mkdir is make directory. And usually in the past when I've done this, I've made it my name so that if I'm collaborating with someone, they know, okay, I need to go look at this thing that Libby did, and they go into my folder. Um, let's see here. Do I talk about? Okay. Sorry, one second. I thought I talked about DVS before I talked about this DVS mount. Okay, so I'm gonna skip to this and then go back to the other thing real fast. So we use something called DVS on our system for I/O. It's basically meant to be a way of handling I/O on our system. This is something that Cray uses. Cray is the vendor who made our system. Um, and so because it's a little it, it it works really well. But then there's certain things that are a little finicky that we have some best practices for. And I'll go back to the CFS thing in a moment, but one of them will be a certain amount that you need to use to make your codes run a little bit faster. So if you're using any kind of Conda environment, and we don't do, I'm not sure if we'll talk about Conda environment specifically in tomorrow's talks. Conda is,
Actually, I'll talk about it next.
oh, you're gonna show it next. Okay, great. So this is a way of setting up basically any like libraries and such that you'll need. They should, what we recommend is to have them in a container or in global common. because this is going to make it much faster for this DVS process to occur. A lot of times we were seeing when people put this stuff in their home directory, it was causing problems when they were running at scale. So if you're trying to run like on a bunch of different nodes. So it's really important if you are planning to use Conda environments, this might be more specific to you, but you'll need to keep in mind how to do this with DBS. In general, if none of this is making sense to you, which I totally understand, the best choice in general is to just run from scratch. You may not have to deal with any of this if you are running in Scratch. If all of your stuff is there, if you put your stuff in Global Common Software, you run it from scratch, you may never have to interact with any of this. But if you're in a situation where your data is too large and you need to run from CFS, we would recommend that anytime you're putting in a file path in your, let's say your submit script or in your input script or whatever, you're going to point, instead of using the global mount, you're going to use the specific DVS read-only mount. And this is going to make your performance when you're running from CFS way better. Um, so just to recap, we recommend running out of Scratch, but if for some reason you can't run out of Scratch because you have too much data, you can run from CFS, but we recommend using this read-only mount of CFS. Okay. And then there's a couple other tidbits here, which I'm not going to go too much into detail. So let me go back now. Um, okay, so this is basically what this is saying. This DVS read-only mount is the best practice if you're going to be running a job from CFS. And again, if you're very new and this like running jobs thing isn't making sense, some of this will make way more sense tomorrow once we talk about what it means to run a job. So it's unfortunate that we can, there are certain parts of this where like until you know what the file systems are, running jobs doesn't make sense, and if you don't know what running jobs is, the file systems don't make sense. So if some of this isn't making sense yet, just hang on until tomorrow, and I think it'll come together. And the most important thing here I want you all to remember is that your data is not purged like it is with um, Scratch, until you are no longer a user of NERSC. Okay. And so the other things I've included in these slides is just some quick reminders of how to access certain things, like the snapshots and so forth, but I'll let you look at those when you're ready to use them. Okay, we talked about HPSS. So like I mentioned, once you're done with your paper, once you're done with the raw data, you want to keep it stored, you're going to use HPSS. So there's some details here. I don't want to go through all of them because I want you to take a look at them yourself. Um, the archive docs page is going to be your best friend if you're actually going to be using um, HPSS. It's going to tell you exactly how to do it. It's not the same. You can't just do CP, if you're used to doing like moving data around, you can't just do MV, HPSS or CP HPSS. There are specific commands that you have to use. In general, you don't want to be moving a bunch of small files. You actually want to tar everything together. And so there's a command called htar. You're gonna bundle everything up, and then you're going to use the commands that they give you to save them into HPSS. So we NERSC has provided these tools, HSI and HTAR. Those are the tools you're going to use like for bundling and then moving your data. And the docs page is going to tell you exactly how to do it. So you probably will just end up copying and pasting commands if you're new to using HPSS. But the main thing to remember here is it's not for small files. It's for you want to bundle up all your small files into a big file, and it's for data that isn't going to be used very often. So if you're going to need this data, don't move it to HPSS yet. If you move it and then you realize, like, obviously that's fine, there's nothing wrong with that. But if you know you're going to be using it, don't move it until you're ready to set it aside for a while. Um, your home directory is where you land when you first log into Perlmutter. Like I mentioned, my analogy of Perlmutter being a house, you're entering the house in this foyer. That's your home directory. So it's a good place to keep a couple small things. I mentioned the quota is 40 gigabytes. It's not huge. One of the things I see most common when people are like, "Oh, I'm not able to run," or something's going wrong, it's that they've saved too much stuff into their home directory and they're over quota. So the first thing I do is we have a command called show quota. You can run it on Perlmutter at any time, and it will show you how much of each of these spaces you've used up. Just keep an eye on that home directory. If you're putting stuff in there, we now have a place where we want you to put your Conda environments to make things easier for you, so you don't end up accidentally filling up your home directory, because that will mean you can't use the system until you've cleaned out your home directory. So that 40 gigs goes by real fast. So in general, put stuff other places. It's really not intended for running jobs. Put everything you need for your jobs in other places, Scratch, Global Common, so forth. Um, and there are these snapshots. I didn't know about this backed up monthly by HPSS. That's cool. But in general, you're going to want to act, if you need to go back, if you need to revert to anything, you can always go back to the snapshots. And the instructions there's some instructions right here. There's instructions, of course, in our documentation, but the snapshots are only for a few days. Um, yeah, okay. I think that's all I want to say about that. Okay, I've definitely said this multiple times, so I don't want to just keep saying the same thing over and over again, but if you haven't figured it out yet, Scratch is your friend when you're running jobs. Global Common Software is your friend for your software stack. Um, if you're, well, this just says don't generate million files, small files. In general, that's not good for IO. It's gonna make things bad. It might make things bad on the system. If you're in a situation where this is happening, you may want to reach out to us or maybe the developer of your code or something and think about ways to aggregate these within, the way you're running your job or whatever, so that the writes are happening into bigger pieces rather than a billion small pieces, okay? Because this can, in general, make your performance really bad, but it's also just not a good way to use the system, not a good way to use this big HPC system. Okay, good. We talked about that. Um, so let's see, how am I doing on time? I'm always going over time. Okay, so within NERSC,
Okay, take your time because we have a lot of flexibility at the end. So, don't feel the need to rush through.
okay, okay, good. All right, I'll slow down for a second. Are there any questions coming in that I should pause and answer, or is the Q&A
So
sufficient?
far, so far, so good.
Good.
Justin and Helen are handling appropriately, so we're good.
Amazing. Okay, thank you so much. Okay. Um, yeah, so the I mentioned in the very beginning that NERSC wants to provide ways for you to store your data, but also if you need to share your data or work with your group on certain data. So there are ways of sharing data within NERSC, and then I'm going to show you ways of moving data in and out of NERSC. So the community file system, again, is shared with your project. So the permissions in there will make it so that everybody has access to certain spaces that are read-writable to readable, writable to everybody. And then if you need to make further changes, there's something called the PI toolbox, excuse me, which can be used for managing further permissions, changing things, and we have a link to it here. But there's also, like I mentioned, that Unix file permissions page, which will help you do certain things. You don't need this toolbox necessarily, that you can do just in the command line. And HPSS is also group writable and readable by default. So if you write something to HPSS, other people in your project would be able to access that data as well. So that's a good way if you want to share a large amount of data, you can put it into CFS or into HPSS, and then if someone needs to access it later, they can just go there. You don't have to give it to them in some way. You don't have to send, mail them a USB or something like that. There are some collaboration accounts. So these are, for example, if you know what the ALS is, there's the Advanced Light Source here at at Berkeley National Lab. These are collab. There's the DAISY DESI collaboration. So we have a couple large collaborations that we manage or help them manage their data in a way that's shareable across that collaboration. So if you're part of that, you can find out more about that from your PI, or talk to us. There is a way to share data with Scratch, and there's some instructions here if you've used the chmod change. I don't know what is the mod part of chmod, but this is to use to change the permissions on a file, and will tell you or in that Unix file permission documentation page, it'll tell you how to do this for some common things, like if you want to change, if you want to give someone access to something on Scratch, you can follow these instructions here. And then the really cool thing we have, which is really nice, is this give take sort of utility. So this is something that NERSC provides. NERSC staff have written this way of doing. You can basically type in once you're signed into Perlmutter into the system, you type give. There's a flag minus U, and then I think the name of the user, and then the file that you want to give them, or multiple, or I think you can specify multiple files, or maybe you have to just do it once per file. I don't remember exactly. But then the other user will actually get an email saying XYZ person has given you a file, like you need to go take it. And then they'll basically do the reverse on their end. They say take, and then they'll type in the name of the user who gave it to them and the file that they were given, and then they get a copy of it. I'm not sure. I mean, I think you can use this on most any file. It may I haven't used this for like really large files, I don't think. But you could. And if you're trying to share a large file and you're having problems, you can always reach out or go look at the documentation. But this is really good if you're trying to send someone your Slurm script, your job script, or an out log, like a log or something like that, especially for small files. Can be really, really helpful. Um, oh yeah, look, I gave myself a how-to on how to do this. Yeah, so you say give the name, the person who's going to receive it, and then the file. I don't know if you can do an entire directory, actually. I should double check that. And then the other person, like I said, they'll get an email, and then they can go sign into Perlmutter and then type in take, who sent it to them, and the file name. And they'll get that email will tell them what the file name is. You don't have to like magically guess or even ask the other person. You'll see what the name of the file is. If you need to share externally, there's a couple different ways to do it. So your project has a public space. So if you have data that you want to share with the whole world, they can do that. And this will be public, like HTML access to that data. Um, and so then you would have this URL that you could actually give people and say, hey, okay, our data is here. So that's one way to do it. We also support these science gateways, which is actually a way for you to make like almost like a web portal. You can have some more sophisticated, like almost like a web application using Spin. This is a service that we provide. If you want to use Spin, we actually have an entire training on how to use Spin. But this is another way you can share your data or make it available to the broader community. And then another a really useful method is to use Globus. So Globus is a file sharing you utility, website system. I'm not sure exactly what the correct word is for it, but it's basically a way to use the internet to send people data. And so this is really, really, really good for large volumes of data. So if you're doing, um, you know, huge transfers, we recommend using Globus, and we have really good documentation on how to use it, step-by-step instructions. We also have specific nodes which are dedicated for data transfer. So these are nodes that you would SSH into directly, just to move data around, because they're set up in a way that provides really good performance for moving data. And in particular, there's other facilities nearby that are not physically nearby, but related to us that we know people are going to be using often, we have a lot of collaboration with. And so we specifically have monitoring of those pathways of, how is data getting transferred, and we can help you with that process. Um, and then some in general, you can also always so for if you're logged into a DTN, you can use SCP, which is secure copy, to move data around from the computer, the location on Perlmutter to wherever it is you're trying to go, or wherever it is you're trying to put that information. So it's important that if you're on a data transfer node, you only use it for data transferring. Don't SSH into a data transfer node and then start, running your job on it or something like that. That's not the purpose of the data transfer nodes. They're meant to be used only for doing data transfer. Okay. Um, yeah, if you need to use Globus to move large amounts of data in and out of NERSC, I recommend using the documentation for this. So it's something that's available to all NERSC users. There's endpoint, NERSC actually helps you by providing certain endpoints on DTNs. There's even a GUI for dragging and dropping files. It's a really powerful tool. You can get it on your personal computer so that this process becomes really simple, and all of that information is here. So if you have collaborators outside of NERSC and you know you're going to be moving data in and out, I would really recommend familiarizing yourself with Globus, and we have a lot of experts at NERSC who can help you if you have any trouble. But I think this documentation, the last time I looked at it, is extremely thorough. So again, our documentation is meant to be for things that we know a lot of our users are doing. We want to just make it easy to just copy paste, and you shouldn't even have to ask us for help because ideally we've set it up for you. Yeah, so like I said, full instructions, really, really fantastic instructions. Okay. Um, I'm gonna skip that for a moment. So I think I'm actually done, which is great. So this is just meant to be, and you'll see this in that beginner guide if you're looking in that beginner guide. It's the same information that I presented at the beginning, just to kind of remind you, it's like a cheat sheet. So if you find yourself being confused by any of these, or you want to just remember, what are these things? If you want, you're welcome to keep this little cheat sheet handy for yourself. And that way, there might be times when you need to figure out, like, okay, what exactly am I doing? Which one am I supposed to be using? And hopefully some of this information can help you. Our documentation, there's so much information in there, that what I tried to do here was just distill a little bit of that into probably the things you'll need to know the most. And then once you're ready, once you've decided, like, okay, clearly I need to use CFS for this because, I don't have enough room in Scratch or whatever, then you can go and look more into detail. And the reason you see like a bunch of clothes hanging in the back, like I said, for my analogy, um, you know, not profoundly creative or anything, but think of the closets in your house. Think of the cabinets in your house, right? Different parts of your house have different types of storage. Some of those storage, I have a drawer next to my bed, which keeps my phone charger. So I grab that every single night. It's super fast and convenient. But I have all my tools in the garage because I don't use them all the time. So that's something I have to go out and get, kind of like HPSS. It's there. I know it's there. It's stored. It's safe, but I don't use it very often. So like I don't keep it next to my bed, right? I keep it in the garage. So that's sort of the analogy of the different storage spaces in Perlmutter, on Perlmutter. Okay. As always, welcome. I hope that wasn't too overwhelming, and if it was, please make sure you ask lots of questions. And yeah, I think that's it for this presentation.